Now that we have a visual sense of what this common tangent with a positive slope would look like, let's see if we can get some constraints on it, especially constraints on its slope and y-intercept. So this line that I drew in the last video here in pink, it would have the form y is equal to mx plus b. It's a line where m is the slope and b is the y-intercept, where b is the y-intercept. Now, let's think about what constraints there would have to be on m and b if this is tangent to the circle. And you might be tempted to break out some calculus and figure out the slope at any point alongside a circle. But there's an easier way to do it. You just have to realize that if a line is tangent to a circle, it will only intersect that circle at one point. Let me show you what I'm talking about. So this is the line. What I want to do is figure out where this equation and the equation of the circle intersect. That's what we'll focus on in this video. And then we'll do the same thing for the hyperbola. So we have y is equal to mx plus b is the equation of the line. The circle, they give us the equation up here, x squared plus y squared minus 8x is equal to 0. So the circle is x squared plus y squared minus 8x is equal to 0. So we have, what we can do is we can substitute this expression over here. We can substitute this in for y, and then we can figure out what does m and b, or what are the constraints on m and b, so that we only have one solution to the intersection, where we only intersect at one point. So to do that, actually, let's substitute for y squared. So if y is equal to this, let's square that. We'll get y squared. I'm just squaring the expression for the line. Y squared is going to be equal m squared x squared plus 2mbx plus b squared. All I did is I squared this expression here. And I did that, so now we can substitute this whole thing right in here for y squared. And so the x point, the expression for the x point for our intersection is going to be x squared plus all of this business, that's the y squared, plus m squared x squared plus 2mbx plus b squared minus 8x. Minus 8x is equal to 0. And if we wanted to write this as a quadratic in terms of x, this would be, so our x squared terms are these two terms. So this is, we could write this as, let's write this as m squared plus 1 times x squared, right? M squared plus 1 times x squared. And then our x terms are this one and this one. So then we have plus 2mb minus 8 times x. And then we just have this b term, this b squared, the constant term right over here. And I'll do that in orange. So plus b squared is equal to 0. So if we knew m and b, if we knew the equation of this line, this would just be a straight up quadratic. You could use the quadratic formula to figure out the x values where they intersect. Now, what's neat about this is we know that they only have to intersect in one point. Remember the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And don't get this b confused with the y-intercept b. This is just the b from the quadratic formula. That's the quadratic formula over there. This will only have one solution. Will only have one solution if this over here is equal to 0, because then you're just adding and subtracting 0. So you're only going to get one solution. So when a line is tangent to a circle, it can only intersect in one point. Or another way to think about it, this will only have one solution. If a line intersects any other type of non-tangent line, a non-tangent line would do something like that. It would either have two solutions, in which case this is a positive value, or it won't intersect at all. Or it won't intersect at all, and then this will have no solutions, which means that b squared minus 4ac would be a negative number. So we know that this is a tangent line. This is a tangent line, so we only have one solution, or b squared minus 4ac is equal to 0. So what's b squared minus 4ac over here? Well, this is our b when we think in terms of the quadratic formula. And remember, don't get that b confused with the b of the y-intercept. I'm just thinking of the quadratic formula here. So let's do this. Let's take this squared. So I'm just going to rewrite this expression and set it equal to 0, because we know there's only one solution. So we have 2mb minus 8 squared. And then you have minus 4 times a, which is m squared plus 1, times c. Times c is b squared. Times c is b squared. And so this is going to have to be equal to 0 if this is truly a tangent line. If this is truly a tangent line. So let's see any type of interesting things that we can get out here. If we can have, or if we can express b as a function of m. That's a good place to start. So let's try to do that. So let's see, if we expand this out, this becomes 4m squared. Let me do that in the same blue so you know what I'm expanding out. This part over here becomes 4m squared b squared. 4m squared b squared minus 2 times 8 is, 2 times negative 8 is negative 16. Multiply that times 2, so it's negative 32mb. I'm just squaring this over here. Plus 64. So that is that term over there, expanded, minus 4 times, let me write this, well, I can just expand everything out. Minus 4 times m squared b squared minus 4 times 1 times b squared. Minus 4b squared is all going to be equal to 0. And then lucky for us, some of these terms cancel out. 4mb squared, negative 4mb squared. And let's see, we could actually divide everything, both sides of this equation, by 4. And we get negative 8mb plus, we're dividing everything by 4, so plus 16 minus b squared is equal to 0. And now we can solve for b in terms of m using the quadratic formula again. So now we would have a constraint, or we would essentially know what our y-intercept is going to be in terms of our slope. And then we can do that for the hyperbola, and then we can essentially say, well, it's the same line, so the y-intercepts have to be the same, and then we can solve for the slope. So let's do that, and you'll see that over the next few videos. So let me just write this in a form that we would recognize. This is the same thing. Well, let me just actually, and let me just multiply this equation right here, both sides by negative 1. So then it would become b squared plus 8mb minus 16 is equal to 0. I just multiplied this by negative 1 and just rearranged the terms. Now let's solve for b in terms of m. So b is going to be equal to negative 8m plus or minus the square root of this term squared. So it's 8 squared m squared minus 4 times a, which is just 1, times c, which is 16, minus 4 times negative 16. So this is, you could view this as plus 4 times 16. Plus 4 times 16. All of that over 2a. Well, a here is just 2. All of that over 2. Now, this is going to be equal to negative 8m plus or minus. Now, this is 64. This is 64. So we can take out, factor out the 64 from here, but when you take the square root of it, it's going to be 8 times m squared. 8 times m squared plus 1, right? If you took the 8 in, you'd have to square it, so it becomes 64, and 64 times m squared plus 64, which is exactly what you had up there. All of that over 2, and then we can simplify it. This is equal to negative 4m plus or minus 4 times the square root of m squared plus 1. So this is a possible b, given that the line is tangent to the circle. Now let's just think about this a little bit. If we add 4, we're definitely going to have, well, let's think about it for a second. If we look at the line up here, the way I draw it, we want a positive slope. And in order to do that, the way I drew it, you have to have a positive y-intercept. So this is a positive, let me just write it this way. This is a positive b, a positive y-intercept. So we want this value. We want to think about the y-intercept that is positive. Now, m is going to be positive. We know from the problem that we're looking for a positive slope. So m is positive. So negative 4, this whole term is here, is going to be negative. So our only chance of being positive is if we add 4 times this expression right over here. And actually, if you look at it, it will be positive because this is greater than m squared. So this is going to be, the square root of that's going to be greater than m. So 4 times this is going to be greater than 4m. So if we add, it's going to be positive. So we want to only look at the b is equal to negative 4m plus 4 times the square root of m squared plus 1. I'll leave you there for this video. In the next video, we're going to do the exact same thing for the hyperbola, realizing that the line will only intersect at one point. And then, since it's the same line, we know that their b's have to be the same. We're going to, in the next video, we're going to get a b is equal to some other function of m, is equal to some other function of m. We're going to get that in the next video. And then we can set them equal to each other and solve for our m. And then once you solve for an m, you also have solved for the b, and we'll have our line. The circle x squared plus y squared minus 8x equals 0, and the hyperbola x squared over 9 minus y squared over 4 equal 1 intersect at the points a and b. Equation of a common tangent with positive slope, so of a common tangent with positive slope to the circle as well as to the hyperbola is. So let's just visualize what they're asking first. And this is going to take us multiple videos, I have a feeling. But let's just visualize it just so we can get our head around the problem. So this circle, let me complete the square in terms of x. So this circle, as they wrote, is x squared minus 8x. And then we have a plus y squared. I left some space here so that we can complete the square, is equal to 0. And then let me add half of this 8 term squared to both sides. So half of negative 8 is negative 4. Negative 4 squared is 16. So add 16 to both sides. And that allowed me to turn the x term into a square, a perfect square. This is the same thing as x minus 4 squared. And then we have plus y squared. Plus y squared is equal to 16. So this is a circle. This right here is a circle with center at x is equal to 0. Sorry, at x equals 4. At x equals 4, y is equal to 0. And it has a radius. It has a radius of 4 as well. So let me graph this circle here. So let me draw the horizontal axis, my x-axis. Let me draw the y-axis. That is my y-axis over here. And let me draw its center. So 1, 2, 3, 4. 4, comma 0. That's its center, and it has a radius of 4. So it's going to come out. It's going to look something. It's going to look something. I could draw a better circle than that. It's going to look something like, that's the top half, and then the bottom half is going to look something like that. So that's our circle. Now let's think about the hyperbola. Let's think about the hyperbola. So if we just look at it, the x squared term is positive. So it's going to be a hyperbola that opens to the right and the left. And we do this a bunch in the conic sections videos if you want a review of that. And we could just figure out where it intersects the x-axis. So then when y is equal to 0, we have x squared over 9 must be equal to 1. Or x would be plus or minus 3. So the hyperbola is going to look like this. So this is at plus 3, comma 0. The hyperbola will open up like that. Will open up like that. And then at 1, 2, 3, negative 3, comma 0, the hyperbola is going to open up to the left. And so in the problem when they describe the points a and b, they're probably talking about that point a and that point b. Now let's think about what this question is asking us. Equation of a common tangent with positive slopes. Has to have a positive slope to the circle as well as to the hyperbola. A common tangent. So let's just think about this a little bit. So it's going to have a positive slope. So it's going to have to, so it won't be tangent to the circle anywhere where the circle has a negative slope. So it can't be tangent. It can't be tangent over here. Can't be tangent over there. And then we could say, well, if it was tangent to the circle over here, what would happen? Well, it wouldn't be able to be tangent. It wouldn't be able to be tangent to the hyperbola. So it has to be tangent to the circle someplace in this blue region, right over here. And then how can it be tangent to the hyperbola? It might be tempting to say that it would be tangent to the hyperbola in this way somehow. But what you need to realize is the hyperbola is asymptoting towards some line, and we could figure out what that line is. It's asymptoting towards some line. So let me draw that line. It's asymptoting. And so it's always it's always going to have, the hyperbola is always going to have a higher slope than that line. It's very slightly higher slope. It's slowly approaching that line. So if you go out here, the hyperbola is going to have a higher slope than the asymptote line. And so if you had to be tangent to it, you would have to have a higher slope. You would have to have a higher slope. And anything that's coming from this part of the circle towards anything out here on the hyperbola is going to have a lower slope than the tangent line, right? Because it's going to have to catch up. The tangent line is going to have to catch up to whatever, let me draw it again, to whatever we draw over here. I want to make this clear. The hyperbola as you go out here, actually this whole period, this whole area, this whole part of the hyperbola is going to have a higher slope than what it is asymptoting towards. That's what allows it to get closer and closer to that line. So any tangent is going to have a higher slope out here. Anything tangent to the hyperbola is going to have a higher slope than this actual line. It's going to have a slightly higher slope. So if we take something out here and we try to draw a tangent from this part of the circle out there, it wouldn't work. Because this tangent, by definition, will have to, in order to meet the hyperbola, is going to have a lower slope than this asymptote. So this can't be tangent to that part of the hyperbola. So what else can we do? Well, the only other part of the hyperbola that we might be able to work something out is this part of the hyperbola, right over here. So if we find a line that's tangent maybe there and there on the hyperbola, then we might have found our common tangent with positive slope. So let me draw that. So our common tangent with positive slope, let me do that in, I'll do that in pink. Our common tangent with positive slope could look like that. So now that we have the visualization down, in the next video, let's try to figure out what that line might look like, especially when we constrain it when we constrain it to having to be tangent to this circle and having to be tangent to this hyperbola. In this video, we're going to do with the hyperbola the exact same thing we did with the circle. We're going to find constraints on the y-intercept for the tangent line in terms of m. But this time, we're going to use a hyperbola. And then we can set them equal to each other and solve for the m. So let's remind ourselves what the equation of the hyperbola is. They give it to us right over there. It's x squared over 9 minus y squared over 4 is equal to 1. Let me write this over here. So it is x squared over 9 minus y squared over 4 is equal, I'll write the y squared, minus y squared over 4 is equal to 1. But now we can substitute the y squared with the y is equal to mx plus b that we got from the last video. And we actually figured out what y squared was equal to. Y squared was equal to all of this business up here. Because it's the same line. Remember, this is the whole point of it. We're trying to find two constraints on that same line. So we can rewrite this same thing. And actually, one thing I want to do is I'm going to multiply both sides of this equation by 36, the common multiple of 9 and 4, so that I can get rid of these fractions. And so this is going to become 36. Let me write it this way. So 36 divided by 9 is 4. So it's 4x squared minus 36 divided by 4 is 9. And I would put a y squared here, but we know that y squared is the exact same thing as this thing over here. So y squared is the same thing as m squared x squared plus 2mbx plus b squared. And then this is going to be equal to, remember, we multiplied both sides of this equation by 36. So this is going to be equal to 36. And let me simplify this. And we're going to do the exact same thing. We know that the m and b have to be such that, or the line has to have a slope and y-intercept. Will only intersect with the hyperbola at one point. It'll only have one solution to this quadratic in terms of x. But let's simplify it first before we worry about that. So this is equal to 4x squared minus 9m squared x squared minus 18 mbx minus 9b squared. Just multiply it there. And let me subtract this 36 from both sides. So then we have minus 36 is equal to 0. So this is a quadratic in terms of x. But let me combine the various degreed terms. So these are the x squared terms. These are the x squared terms right over here. So this is the same thing as 4 minus 9m squared times x squared. And then our only x term is this right over here. That's our only x term. So this is minus 18mbx. And then our constant terms are right over here. So this over here is minus 9b squared minus 9b squared. Let me write it this way. Let me write it as minus 9. Let me write it as, well, I'll just write it minus 9b squared minus 36. I'll just write it like that. And of course, that is going to be equal to 0. And remember, quadratic formula, if we wanted to solve for the x's, we'd have the quadratic formula. But we only want to have one solution. So the discriminant part of the quadratic formula is going to equal 0. The b squared minus 4ac is going to be equal to 0. This is exactly what we did in the last video. So let's take the b squared minus 4ac and set that equal to 0. And then we'll have our constraints on m and b. So b squared is, and remember, don't get the b squared in the quadratic formula confused with the b in the y-intercept. But this term squared is, so this is going to be, it's going to be 18 squared m squared b squared, right? Negative 18 squared is just positive 18, minus 4 times a. A is 4 minus 9m squared times c. So c is, so I can rewrite c as negative 9 times what is this? Negative 9 times b squared plus 4. Did I do that right? Negative 9 times b squared is negative 9. B squared, negative 9 times 4 is negative 36. I want to make sure I don't make any careless mistakes. And so this becomes, so if we just take the negative 9 and the negative 4, they become a positive 36. They become a positive 36. And then we can actually, let's see, just to simplify things so that we don't have to do too much fancy math, this 18 squared, let's remember, 18 squared is the same thing, well, 18 squared is going to be divisible. Well, I won't worry too much about that just yet. I just want to make sure that, actually, let me write it this way. So 18 squared is 2 times 9 times 2 times 9. Or another way to think about it, it is 4 times 9 times 9. That's the same thing as 18 squared. 4 times 9 times 9. Now we can divide both of these terms. We can, and this whole thing, remember, we want this whole thing to be equal to 0. The discriminant has to be equal to 0. So we can divide both sides of this equation. We can divide both sides of this equation by 36, which is the same thing as dividing by 4 times 9. So this term right over here, we can get rid of 1, 4, and 1, 9. And we're going to get a 9m squared b squared over here. And then we divided by 36, so these all go away. So it's going to be 9m squared b squared plus this thing times this thing, plus this thing times this thing. So let's see what that is. So we have a 4 times a b squared. So we have plus 4b squared. Let me do this in a different color. Do it in blue. So plus 4b squared. And then you have 4 times 4, so plus 16. Then you have negative 9m squared times b squared. So it's negative 9m squared b squared. And then you have negative 9m squared times 4. So negative 36m squared. And that's going to be equal to 0. Lucky for us, that and that cancel out. And then we are left with something. And actually, what we're left with, everything is divisible by 4. So let's divide what we're left with by 4. So then we're left with b squared, that's that term. And then minus 9m squared, minus 9m squared. That's that term over there, just divided it by 4. And then plus 4 is equal to 0. And once again, well, actually here, we don't have to do anything. We don't have to use quadratic formula. We can just solve for b. We could subtract this from both sides. And so we'll get b squared. B squared is equal to the square root of 9m squared, minus Square root of 9m squared minus 4. Sorry, that's not b. b is equal, let me just write this. I don't want to skip steps here. b is equal to, listen, b squared is equal to 9m squared minus 4. They're painting the office right now, so maybe it's making me a little bit, making my brain not work properly. And then b is equal to the square root of 9m squared minus 4. Did I do that right? Let's see. I got the 4. Yeah, it looks right. And so we're left with a situation where the b, if we're saying that the line is tangent to the hyperbola, it has to be this. And if the line is tangent to the circle, b has to be equal to this business over here. So let me copy it, and then let me paste it. Let me paste it just like that. And so we now have two equations with two unknowns. We can set these equal to each other and solve for m. And this will give us the m, or the slope, of that tangent line. And then we can go ahead and solve for b. I'll do that in the next video. We're in the home stretch. We figured out the constraint on b in terms of m for that line that's tangent to both the circle and the hyperbola. I want to make one clarification here. Here in the last video, I took the principal root when I took the square root. And that's because I want the y-intercept to be positive. Remember, when we look at this drawing that I did in the first video over here, this y-intercept needs to be positive in order for it to have a positive slope and be tangent to both the circle and the hyperbola in this way. And so down here, you definitely want to take the principal root. Now with that said, this is the constraint from the hyperbola. This is the constraint from the circle. Let's set them equal to each other and solve for m. And then we'll have our slope of the line. So let's set them equal to each other. So we have the square root of 9m squared minus 4 is going to be equal to negative 4m plus 4 times the square root of m squared plus 1. So the first thing we can do, let's square both sides of this. So we get 9m squared minus 4 is equal to this term over here squared. So this is 16m squared. And then plus 2 times the product of these two terms. So the product is going to be negative 16m. So it's going to be negative 32m times the square root of m squared plus 1. And then plus, square this term, 16 times m squared plus 1. So let's try to simplify this a little bit, get maybe the radical on one side of the equation, and see if we can simplify this even more. So a good place to start. So let's see, this term right over here is going to be a 16m squared plus 16. So on the right-hand side, let me just write it like this. We have 9m squared minus 4 is equal to, on the right-hand side, we have 16 plus 16. We have 32m squared plus 16 minus 32m times the square root of m squared plus 1. And let's see, we can subtract 9m squared from both sides. So we'll subtract 9m squared from both sides. And then we can add 4 to both sides. And then we are left with, actually, let me do it the other way, because I want to isolate this on the right-hand side. Let me do it the other way. So let's subtract 32m squared from both sides, minus 32m squared from both sides. 32m squared from both, well, yeah, might as well do it this way. So subtract 32 from m squared from both sides, and then subtract 16 from both sides. The left-hand side, 9 minus 32 is going to be negative 23, because 23 plus 9, yep, so this is negative 23m squared minus 20 is equal to negative 32m times the square root of m squared plus 1. Now we can square both sides of this equation. It's not the cleanest problem in the world, but hopefully if we haven't made any mistakes, we'll get someplace productive. Actually, let's multiply both sides of this equation times -1 just to make it positive, simplify things. So that becomes positive, positive, and positive. You square the left-hand side of the equation, we get 23 squared. Let me write it this way. We get 23m squared squared plus 2 times the products of this. So this would be 40. Let me just write 2 times 20 times 23 m squared plus 20 squared, which is 400, is going to be equal to 32 squared, or I'll write this 32m squared times m squared plus 1. And let's see what we can do over here. So this turns into, this is just a big tedious problem. So I'll just write this as 23m squared squared plus, so this is going to be 40. This is 40 times 23. So 23 times 4 is 92. So it's going to be plus 920 m squared plus 9. Actually, let me expand everything out here. Let me just go straight to the numbers. So 23 times 23. 23 squared. 3 times 3 is 9. 3 times 2 is 6. 69. Put a 0 here. 2 times 3 is 6. 2 times 2 is 4. So you get a 9. 6 plus 6 is 12. 1 plus 4 is 5. So you have 529 m to the fourth plus 40 times 23. 4 times 20 is 80. 4 times 23 is 92. So it's going to be plus 920 m squared plus 400 is equal to, so we're going to have 32 squared. So let me figure out what 32 squared is. 32 times 32. It seems like if you're taking this exam, you might as well have your multiplication tables memorized to about 50. And I think they do that on purpose. So just so you get a sense, I mean, this isn't an exam where the test takers expect everyone to get a perfect. The threshold, I think the #1 score in India is on the order of 80% right, which is pretty darn amazing to be able to do roughly the math section in about an hour. To get 80% right is pretty amazing. But I think to make the threshold of getting into these highly selective colleges, I think you have to get around 40 or 50% correct. Forgive me if I got that number wrong, but I think it's on that order. So they need to do that because you have 200,000 or 300,000 people in India taking it, so you need to make sure that you have a good spread of people. So this is what they do to spread people out. So we have 2 times 2 is 4. 2 times 3 is 6. And they put a 0 here. 3 times 2 is 6. 3 times 3 is 9. And for example, if I was preparing for the exam, I might even go ahead and and you know me, I hate to memorize things, but if you had to do this type of problem on the order of 5 minutes, you might want to memorize these type of things ahead of time. The y-intercept for a line that intercepts a hyperbola, y-intercept for a line that intercepts a circle, who knows? But anyway. But in general, I don't think it's good to memorize in life, because when you're actually doing math problems in your life, what matters more is you understand the underlying meaning, and you normally have plenty of time to do it in your real life. These exams are kind of an artificial circumstance. But anyway, 4 plus 0 is 4. 6 plus 6 is 12. And then you have, so it's 1024 is equal to 1024. That's the 32 m squared times m squared plus 1. Or another way, this is 1024 m to the fourth plus 1024 m squared. And now we are in the home stretch. So let's subtract 529 m to the fourth from both sides. So minus 529 m to the fourth. This is extremely tedious. Minus 529 m to the fourth. Frankly, at this point in the problem, you're better off, if you just want to do it for speed, just trying out the choices they gave you and figuring out which m's and b's satisfy that. But anyway, let's just move forward. Or which m's satisfy. That'd probably be faster. But let's just solve it properly. So minus 529 m to the fourth plus, and then we also want to subtract 920 m squared. So let's also subtract 920 m squared. And so on this side, we're just left. Let's also subtract a 400 just to make this a proper quadratic. And also we're going to put a 400 here. So the whole left side simplifies to 0 is equal to 1024 minus 529. Let's see, 1024 minus 524 would have been 500. would have been 500. And so it's going to be 5 less than that. So it's going to be 495 m to the 4th. Did I do that right? 1024 minus 524 would be 500. But I'm subtracting 5 more than that. So that is going to be 495. And then 1024 minus 920. See, it's 80. It'll be 80 plus 24. 80 plus, so it's going to be plus 104 m squared minus 400. Minus 400 is equal to 0. So we have just a straight up quadratic equation over here. And you might not recognize it, but this is the same thing. M to the 4th is the same thing as m squared squared. So let's just solve it. So we'll get m squared. We're not solving for x anymore. We're going to get m squared using the quadratic formula. You could substitute x is equal to m squared, and this will just become a natural quadratic then. M squared is equal to negative b, negative 104, plus or minus the square root. More fun math for us without a calculator. Plus or minus the square root of 104 squared minus 4 times a, which is 495, times c, which is negative 400. So that'll make this a positive, and you have a 400 right over here. And then all of that over 2 times 495. 2 times 495 is what? That's going to be 800. It's going to be 10 less than 1,000. So it's going to be 990. 990. So let's try to see if we can evaluate this. Actually, I'll stop this problem here. I'm already crossed the 10-minute threshold. In the next video, we'll just grind through this mathematics. It's really just arithmetic at this point, and figure out what m is going to be equal to. All right, where we left off, we really were in the home stretch, and now we just have this messy arithmetic that we have to solve to essentially find our slope, and then we'll be able to figure out the y-intercept. And since we're actually going to have to take the square root of this eventually, let's just factor each of these terms and see if this hopefully will simplify into something reasonable. So let's just let's just factor 104. I think it'll be useful just to have each of these guys factored. So 104 is the same thing as 4 times 26, right? 4 times 25 is 100. 4 times 26, which is the same thing as 2 times 13. So that's 104. So 104 squared. Let's just worry about the radical right now. So this is going to be this squared. So it's going to be 4 times 4 times 2 times 2 times 13 times 13. That's this right over here. I squared it, so I put each of its factors twice. And then you're going to have plus 4 times, let's factor 495. 495 is divisible by 5. Let's see, 5 goes into 500. 5 goes into 500 100 times. This is 5 less than that, so it's going to be 99. 99 is 9 times 11. So the 495 can be factored as 5 times 9 times 11. And then 400 is pretty straightforward. 400 is going to be times 4 times 4 times 10 times 10 times 10 times 10. And so we can factor out, for this expression right here under the radical sign, there is a common factor of 4 times 4 here. We have a 4 times 4. And there doesn't look to be any other common factor. So this is going to be the square root of 16 times the square root of, it looks like we're actually going to have to do some serious multiplication here. The square root of 4 times 169. So let's just multiply that out. So we're going to have, this is really a painful problem. So let's just say this 4 times, let's see, 13 times 13 is 169. So we're going to have 169. That's the 13 times 13 times 4. So 4 times 9 is 36. 6 times 4 is 24, plus 3 is 27. 1 times 4 is 4, plus 2 is 6. So all of this right over here is going to be 676. 676. And then we're going to have, let's see, 5 times Well, 5 times not, well, we know what this is right over here. This number right over here is going to be 495. And we're going to multiply that. We're going to multiply that times 100. So this is going to be, so plus 495, and just add 2 zeros, 1, 2. So it becomes 49,500. So this is going to become square root of 16 is 4 times the square root. This will be interesting. We're going to do some serious factoring here. Of 49,500 plus 676 is going to be 50,000. 50,000. Let me see. So 176, right? If this was just a 500 here, then we would get to 50,000. We have another 176. So times the square root of this crazy thing. And so let's see if we can factor this. Let's see if we can factor this. This is really, really a nasty problem. So 50,000 looks like it's divisible. Looks like it's divisible by 4. So let's see. 4 goes into 50,000. 176. We're getting some good practice here on our arithmetic. 4 goes into 50. Maybe there's a faster way to do this. 12 times 4. 12 times 4 is 48. You subtract, you get a 21. 4 goes into 21 5 times. You get a 20. Subtract, you get a 17. 4 goes into 17 4 times. 4 times 4 is 16. Subtract, bring down that, you get a 16. So it goes 12,544 times. And once again, this looks like it's divisible by 4, or it definitely is divisible by 4. And let's see, this is going to be, I don't want to make any careless mistakes, so let me just divide it again. I'm tempted to do some of this in my head, but we've gotten so far, I don't want to make mistakes. So 4 goes into 12 3 times. 3 times 4 is 12. 4 goes into 5 1 time. 1 times 4 is 4. You have 14. 4 goes into 14 3 times. 3 times 4 is 12. You get a 2, 24. So 3,136. Once again, this looks like it's divisible by 4 again. This is 4 times, I should have just guessed that this whole thing was going to be divisible by 16 or something. So 4 goes into, don't want to make a careless mistake, 3,136. 4 goes into 31 7 times. You get a 28. Subtract, you get a 3. 33 goes into it 8 times. You get a 32. Subtract, you get a 16. You go exactly 4 times, no remainder. So 784. Once again, this looks like it is divisible by 4. It's getting at least simpler now. 4 goes into 784. 4 goes into 7 1 time. 4. You get a 38. It goes here 9 times. 9 times 4 is 36. You subtract, you get a 24. 196 times. And really, if you are going to take the JEE, I do recommend being able to do this mental arithmetic much faster, because I'm clearly not capable of doing it fast enough. So you have 196, and then 196, this is divisible by 16, I believe. Let me see. 16 goes into 196. It goes into it, well, actually, no, it's not. So let's just do by 4. This is 17, I believe. Let me look at just 4. My brain is fried. 196, 4 times, 16, 36. It goes into 4, goes into 36 9 times. So this is 4 times 49. All right. So if we're taking the square root of all of this business, this is 4 times 49 over here. So this is the square root of 4 to the 5th power. This is 4 to the 5th power. So, or let's do it this way. We could just take the square root of each of these factors. So this in blue, so this is going to become 4 times the square root of this. We could just take the square root of each of its factors. So it's going to be 1, 2, 3, 4, 5 2's. So times 2 to the 5th, which is 32, times the square root of 49, which is 7. So this term right over here, simplified 2. This whole video has been just arithmetic. 4 times, my brain really is fried. So 32 times 4. We have an 8. 4 times 3 is 120. Or 4 times 3 is 12. And then we want to multiply that times 7. I think you can see my handwriting degrade. 7 times 8 is 56. 7 times 2 is 14. Plus 5 is 19. Bring up the 1. 7 times 1 is 7, so it's 896. So all of that stuff in blue was 896. So let's see. All of this stuff over here, was 896. 896. Now, we have to decide, do we do plus or minus? Remember, we want a positive slope. So we want to add the 896. So we're getting m squared is equal to 104 plus 896, or negative 104 plus 896. So if we subtract 104 from this business over here, we're going to get 792, right? 792 over 990. This is what m squared is equal to. And then this looks divisible. Let's see, is it divisible? These are both divisible by 9. So let's divide both of them by 9. Let me clear all of this stuff down here. It's just a big arithmetic video. But hopefully we'll get the right answer. It would be painful if I made a careless mistake earlier on and all of this is in vain and I have to redo the video. So let's hope that isn't the case. So let's divide both of these by 9. 9 goes into 792. It goes into 79. It goes into 79 8 times. 8 times 9 is 72. And then you get 72, so it goes 88 times. So this is, if you divide that by 9, you get 88. If you divide this by 9, you get 110. Now these are both divisible by 11. So if you divide by 11, you get 8. You get 8 over 10. 8 over 10 is the same thing as 4 over 5. Unbelievable. It all simplified down to 4/5. So the slope of our line, m squared, is equal to 4/5. Or, taking the square root of both sides, m is equal to 2 over the square root of 5. So that's the slope of our line. And now we just have to go back to one of these equations, whichever one we think is simpler, and find the y-intercept. This is the simpler one. So m is equal to 2 over the square root of 5. b is going to be equal to the square root of 9 times m squared. Remember, m squared is 4/5. 4/5 minus 4. So what is this going to be equal to? And let me just clear all of this business out here, well, I'll just leave it there. Maybe it'll be useful in some way if I made a careless mistake. Hopefully I haven't. So this is going to be equal to 9 times 4 is 36. So it's equal to 36 over 5 minus 20 over 5. Minus 20 over 5. So this is equal to the square root of 16 over 5. I'm running out of space. So this is equal to, so b is equal to the square, 36 minus 20 is 16. So square root of 16 over square root of 5, or 4 over the square root of 5. And we are done. We now know the slope of that tangent line, the thing that had a positive slope. Its equation is going to be y is equal to 2 over the square root of 5x plus 4 over the square root of 5. And if we want to simplify it, because if I remember properly, that problem didn't have it in, they put everything on the right-hand side. Let's multiply everything times square root of 5. So you get square root of 5y is equal to 2x plus 4. And then we can subtract these from both sides. And we get negative 2x plus the square root of 5y minus 4 is equal to 0. So do they have that as one of the choices? So it looks like they do if we just multiply everything times negative 1. If we multiply everything times negative 1, we get 2x. We get 2x minus the square root of 5y plus 4 is equal to 0. And we are done. This was probably the most painful problem I've done in my life. 2x minus the square root of 5y plus 4. The answer is B. What I'm going to do in this video is something a little unconventional, because I tried this problem before I started this video, and I kept getting an answer that isn't one of these answers over here. So assuming that the exam writers did this properly, and this is a serious exam, it's to get into a very prestigious set of universities in India, so I'm assuming they didn't make any major mistakes here. I want you to tell me where I'm making the mistake. So let's just try to do the problem. Let p and q be real numbers such that p does not equal 0, p to the third does not equal q, and p to the third also does not equal negative q. If alpha and beta are non-zero complex numbers satisfying alpha plus beta is equal to negative p, and alpha cubed plus beta cubed is equal to q, then a quadratic equation having alpha over beta and beta over alpha as its roots is. Did I just call it b up here? It's beta. So what could that quadratic be? Well, these are the two roots, so that's pretty straightforward. We could say that the quadratic, a possible quadratic here, would be x minus alpha over beta times x minus beta over alpha is equal to 0. Clearly, the roots of this equation right here are alpha over beta and beta over alpha. Either one of those will make this expression, would satisfy this equation. Now, let's multiply this out. X times x is x squared. X times negative beta alpha, beta over alpha is negative beta over alpha x. Then you have negative alpha over beta x, so negative alpha over beta x. And then you have negative alpha over beta times negative beta over alpha. The alphas cancel out, the betas cancel out, the negatives cancel out, and you get plus 1 is equal to 0. And then let's see, we might be able to simplify this a little bit. If we multiplied everything times alpha beta, what will happen? So I'm just going to multiply both sides of this equation times alpha beta. Alpha beta. I don't like having things in denominators. Clearly, the right-hand side is still going to be 0. The left-hand side now becomes alpha beta x squared. Alpha beta times beta over alpha. The alphas cancel out. You have a beta times a beta. So it's negative beta squared. Negative beta squared x minus the betas cancel out. And now you have an alpha times an alpha minus alpha squared x. And now you have plus alpha beta is equal to 0. And then we can combine these terms over here. So we have alpha beta x squared minus, you have a alpha squared plus a beta squared. Alpha squared plus a beta squared x, right? I just took the negatives out of it, plus alpha beta is equal to 0. All right, so everything I did is just kind of, I just said, OK, these are the roots. Let me just multiply it out. And I got something in terms of alpha and beta. Now, when you look at their choices, clearly they want answers in terms of p's and q's. So let's see if we can convert this into p's and q's. So a good place to start, they tell us that alpha plus beta is equal to negative p, or negative p is equal to alpha plus beta. And so if we squared that, what I want to do is somehow relate it to q as well. And so maybe if we eventually take it to the third power, we can get some of these terms over here and relate it to q. And also when we square it, I think we'll be able to relate some of these things to it as well. So let's square both sides of this equation. So you have negative p squared, which is the same thing, because the negative is canceled out. This is the same thing as negative 1 times p squared, which is negative 1 squared times p squared, which is just p squared, is equal to this expression over here squared, which is just alpha squared plus 2 alpha beta plus beta squared. Fair enough. And already we have something interesting showing up over here. We can express alpha squared plus beta squared in terms of p squared and alpha beta. And then we simplify things a little bit. Well, let's just keep going. Let's just take this to the third power. So if we have negative p to the third power, which is the same thing as the negative of p to the third, if you multiply this thing times negative p, you're going to get the negative sign, p to the third. And this is equal to, we could just multiply again, do the distributive property. Or if you kind of remember Pascal's triangles, you remember the coefficients on it, or the binomial theorem, this would be a faster way to do it. You start with I'll do Pascal's triangle really quick here if you don't want. So you have 1, 1, 1 for binomial, 1, 2, 1. When you take the square of a binomial, 1, 2, 1. And then when you take that to the third, when you go to the third power, it's 1, 3, 3, 1. A bunch of videos on this, especially in the videos on the binomial theorem. So this to the third power, this thing right here to the third power is going to be alpha to the third plus 3 alpha squared beta plus 3 alpha beta squared plus beta to the third. I just decreased the exponent on the alpha each time and started increasing the exponent on the beta each time. Or you could just multiply this times this, and you should also get this. And now this is interesting because this is expressing everything in terms of, let's see if we can simplify this a little bit. This is equal to, so let me write this. We have negative p to the third, which is equal to negative p to the third, just the difference of the parentheses, is equal to, we have this alpha cubed plus the beta cubed. That's those two terms right over there. And I separate those out because those are our q. Those are our q. And then I have, let's see, over here I can factor out a 3 alpha beta. So plus 3 alpha beta. And what do I get? If I factor out a 3 alpha beta here, I'm just left with an alpha on this term. And if I factor out a 3 alpha beta here, I'm just left with a beta. I am just left with a beta. So what does this simplify to? So this is going to simplify to, this is going to be equal to, this right here is equal to our q. This is equal to q plus 3 alpha beta. And what's alpha plus beta? Well, they already told us what alpha plus beta is. Alpha plus beta is negative p. It is negative p. So let's see what we can do over here. We can, this is right here is the same thing as negative p to the third. So here we can solve for alpha beta. And so we'll have alpha beta in terms of p's and q's. So that'll be good. So we can substitute the alpha betas with whatever we get in terms of p's and q's. And then this thing we can express in terms of a p and an alpha beta, which means we can express in terms of p's and q's. So let me do what I'm talking about. So let's just solve, first of all, for alpha beta. So if we solve for alpha beta, first we want to subtract q from both sides of this equation. So you have negative p to the third minus q is equal to, we have this negative sign over here. So it's equal to negative 3 alpha beta p. And I want to solve for alpha beta. So let me divide both sides by negative 3. And so we get, on the right-hand side, we get alpha beta. Alpha beta is equal to, if you divide, so let me just write it out because I don't want to make a careless mistake. So you have negative p to the third minus q over negative 3p, over negative 3p. Now if we multiply the numerator and the denominator by a negative sign, we get p to the third plus q over 3p is equal to alpha beta. So we can now express this and this term in terms of p's and q's. Now what about this one right here? So what is alpha squared plus beta squared? And we see right up here, alpha squared, that's alpha squared plus beta squared. So if we subtract 2 alpha beta from both sides of this equation, we get alpha squared plus beta, let me do this in a different color. We get alpha squared plus beta squared is going to be equal to p squared, minus 2 alpha beta, minus 2 alpha beta, right? I just subtracted 2 alpha beta from both sides. And so this is going to be equal to p squared minus 2 times this thing, minus 2 times p to the third plus q over 3p. Over 3p. And what is this equal to? This is equal to, let's put on a common denominator, p squared over, this is the same thing as 3. My cell phone rang. I had to pause it. Sorry. So this is equal to 3 p to the squared. If I want to put it over 3p, is equal to 3p to the third over 3p. Let me make it clear. This term right here is this term over here. If you were to simplify it, 3's cancel out. You just have p squared. And then you have minus, I'm just going to distribute the negative 2, minus 2p to the third minus 2q, all of that over 3p. So it is equal to 3p cubed minus 2p cubed is equal to p cubed minus 2q, all of that over 3p. So now we can write this entire expression in terms of p's and q's. This first term over here, alpha beta, this is p cubed plus q over 3p, and we want to multiply that times x squared. And then you have minus alpha squared plus beta squared. We just figured out that alpha squared plus beta squared is this thing over here. So minus, I'll do it in a different color. I'll do it in green. Minus this thing, p to the third minus 2q over 3p over 3p. And that's going to be multiplied by an x, and then plus alpha beta again. So alpha beta is p to the third plus q over 3p. Now, when we look at any of the choices up here, it looks simplified. We don't see any 3p's in the denominator, so let's see if we can simplify that. If we multiply this, oh, and we won't want to lose. We had a equals 0 here the whole time. So this is equals 0. So you multiply both sides of this equation by 3p. What do you get? This first term becomes p to the third plus q times x squared. The second term becomes minus p to the third minus 2q x. And then this last term becomes plus p to the third plus p to the third plus q. And this is going to be equal to 0. Now let's see if how this compares to the choices. And I think I actually did not make my careless mistake in this video. I actually got the right answer. Let me see. It shows you when you do it carefully. You're less likely to make errors. OK, so let's see. How does this match up to what I have over here? Well, this looks exactly. I'm very excited because I tried this twice before actually making the video, and I kept making a careless mistake. But this time I didn't make the careless mistake, and I got b, p to the third plus qx squared minus p to the third minus 2qx plus p to the third plus q. So that right there, is our answer. So I take back what I said at the beginning of the video. I didn't need your help, but I guess just the process of explaining it was the help that I needed. Anyway, hopefully you found that useful.